Hello and welcome to Unit 1, the first video, Functions and Function Notation. Let me get a pen. So determining whether a relation represents a function. So what's a relation? So a relation is, suppose you have this group of things, and then you have this group of things. So a relation would be something that connects these two groups of things. Just any type of assignment, it doesn't really matter, it doesn't have to be a formula, it can be a list. So suppose we defined this relation, and it doesn't, once again, it doesn't mean anything. It's just, I literally just made that up. That's not even in my notes. So it doesn't even mean anything. That's a relation. Now a function is a special type of relation. Right? Because it follows special rules. So usually you can represent a relation with an ordered pair. Right? So you guys are probably most familiar with XY. Something else you may be familiar with is domain and range. Another way to put this for you computer people is input-output. And for you scientists out there, independent and dependent. So those are all different ways of talking about relations. So now you may ask, what is a function? I don't know. Well, it is a relation, see, it's a special type of relation in which each possible input value, now remember, if we're talking about input-output, this is what it would be. So it's where each possible input value leads to exactly one output value. So that means if you give me an input, it's going to give me a single output. Okay? So the input value is the domain, and the output value makes up the range. Now, we're going to look at some examples. Let's say that we have, I don't know, this blob. And these blobs usually represent chunks of numbers. And then this blob, we'll call this our inputs. It's also called our domain. And we'll call this one our outputs, which is also called our range. So we're going to have just random bits of the alphabet scattered in here. So notice that by this definition, it would be possible for two different inputs to have the same output. This is a function. This is a function. It's good. Notice also that we'll do another blob. This one we'll do domain, and I'll abbreviate it. This one we'll do range. Notice also that this is also a function, if each one just has something different. That's a function. That's okay. So also notice if we go back to this input-output model, if I added O here, that's okay. That's still a function. There's nothing really in the definition that says that something in the output has got to be associated with the input, at least mathematically. But what we cannot have is an X that goes to nothing. For reasons that will be specified later, it's very important that we don't have an X that goes to just nothing. Now let me illustrate what's not a function. So I got this blobby, here's another blobby. Once again, this is our domain, this is our range. So let's say we have P and R, M and N. And we'll have Q. So Q is going to go to N. P is not going to go to anything, right? Can't have that. But R will go to both M and N, meaning that we have RM and Rn. Now this is not a function at all. So example 1, determine if menu price lists are functions. Is price a function of the item? So let's make some lists here. Is price a function of the item? To say that price is a function of the item would be to say that for every item we get one price. So when it's listed like something is a function of something else, this is going to be your range, and this is going to be your domain. So for our domain, this is A, we have the item, which is plain jelly chocolate. For the range, we have the price, which is $1.49. And do you see how these two are the same? I'm only going to list that once, because if we're talking about a range of numbers, if our list is 1, 2, 2, 4, we're not going to count 1, 2, 2, 3, 4. The 2 is only there once, essentially, on our number line. So we're just going to list that once. Now, our plain donut is $1.49. Our jelly donut is $1.99. And our chocolate donut is $1.99. Now, does each input value have only one output value? Yes, it does. They may be the same for two of the donuts, but that does not matter for now. So it is a function. So you would say yes. Price is a function of the item. Now what about B? So here we have item listed first. So this is our range and our price is our domain. So our domain is the price. Now notice I'm still going to only list $1.99 once. Our range is now our donuts, jelly, and chocolate. That looks good. So now we can start doing some matching. So looking at our price list, I can see that $1.49, I can get me a plain donut. I see for $1.99, I could get myself a jelly donut, or I could get myself a chocolate donut. And I hate jelly donuts, so I would go for a chocolate donut. So what's the problem here? The problem here is that we have an input value, so a domain value, that goes to multiple range values. So this is a problem. So you could say no. The item is not a function of the price. So it would be the opposite of what we just did. So now we're going to determine if this is a function. In a particular math class, the overall percent grade corresponds to a grade point average. Is the grade point average a function of the percent grade? Grade point average, a function of the percent grade. So that means that our domain is the percent grade. And our range is the grade point average. I'm going to just write GPA because I know all of you guys know what GPA stands for, so we're going to stick with that. And then it wants to know the reverse. Notice this question nestled right in here. We could have missed it. So, is the percent grade a function of the grade point average? That wants to know the reverse. So, is the grade point average a function of the percent grade? Since I have my percent grade up top, I would recommend always putting your domain or your inputs up top and your ranges on bottom. Or if you were to make it in something like this, I would recommend this is your domain and that's your range. That is the most logical. That is what you will see everywhere. So we may as well get used to writing it that way. So is this? Well, look at it. We need one x value to go to only one y value or output. So one input to every output. Well, what happens if I have a 74? It looks like my grade point average is going to be a 2.5. All right, so let me work a little bit harder. Well, it turns out I got busy and I didn't really work that hard. So my grade only went up a 76. Well, guess what? I still have a 2.5. So that means that all of these numbers in between here, so 72 to 70, they all go to 2.5. So if we had to write something like this out, we had 2, 2.5, 3, right? All of these are going to go there. Is this a function? And you can look back at your notes, pictures. Turns out it is. Feel free to pause these videos at any point if you need, just some more time to write things down or work on examples. So yes, GPA is a function. Ooh. Sorry, I don't know what that was. So GPA is a function of the percent grade. Okay. Now let's look at if this was our domain and we had our range. So if we flipped it. Right, something like that. So now is that a function? So is our percent grade a function of the grade point average? Well, let's see. If I have a 2.5, I could have 72. I could have 73, 74, 75. And I mean, it would just, blah, 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 keep going all the way to 77. So looking back at your notes, is this a function? Does each input have exactly one output? No, it does not, because our input can take on any value in that range, which that's not a function. No. Percent grade is not a function of GPA. There we go. Not at all. So function notation. What exactly does function notation look like? That would be something like this. And how do we say that? Well, y is a function of x. It's what we were previously doing, right? You could also say y equals f of x. You could say that. That's more, this is what you're going to hear like 90% of the time, almost 100% of the time. So these input values, one nice little caveat you guys need to know is that they can be expressions. So y can equal f of x, but if my x equals a plus b, then that means my y equals f of a plus b. And I can do that. That is entirely okay. This is how functions are written. Okay, using function notation for days in a month. Use function notation to represent a function whose input is the name of the month. So that's the domain, be our x's, and the output is the number of days in that month. So that's our range, that's going to be our y's. So function notation dictates that this is what it looks like. So you could say the day equals f of the month. Day, the number of days, total number of days equals f of the month. Something like this would look like January, the 30th? February, ooh, that depends on whether or not it's a leap year. I can't help you guys out there. And so forth and so forth. So, example 4, a function n equals f of y gives the number of police officers n in a town in year y. What does f of 2005 equals 300 represent? So, that's the number of police officers, and y, we know, is the year. So if y equals 2005 and n equals 300, right here and here, then we can say in 2005 there were 300 police officers in the town. And that's what that would mean. So representing functions using a table. So like we were saying, there's two ways to do this. This is your domain, and this is your range. This is your domain, this is your range. Now what you do not want to see is like 1, 2, 2, 4, 1, 3, 7, 9, this. Not okay. So that represents the input value going to two separate output values. So remember how we were talking about that's not a function? That's not a function. Still applies here. So if you were to see a table, this is what not a function would look like. So evaluating functions in algebraic form. This video is getting pretty long. I am going to go ahead and call it here, and I will pick this up in video number 2. I'll try to put this one into chunks. So I will see you in the next one.